Hey guys, good day. Steve Hughes here, jumping in to have some more Excel fun with you guys. Today we are talking about topic 5, DQ1. And the first thing, as always, guys, you want to go ahead and type your name in here in cell E2 in this case. Go ahead and type your name in. When you do that, your data is going to populate automatically for you. Prior to that, you'll have value, okay? Once you've done that, let's go to the improvement data in column F, and it says, we want to write a formula that calculates the difference in readings as after minus before. So click on cell F4, and you can see that I have entered equals E4, which is after, minus before, which is D4. Once you've done that, hit enter, and your cell has turned green. The value has turned green, so you know that it's correct. At this point, go ahead and drag it down or just click on the lower right-hand corner, double click, and it will populate all the way for you. Pretty cool stuff, right? All right, now, everybody, we're going to go here. We're going to do our 4 statistics here. We're going to find the mean, which is the mathematical average. We're going to find the median, which is the number in the middle, if organized from least to greatest, the standard deviation, and the range. Okay, so the first two are measures of central tendencies. The last two are measures of dispersion. The mean in Excel is not mean, it's average. Okay, so you're going to type in equals average. And we want to find the average of the data in the well before the treatment. That is column D, right? So just type in D:D. All right, average, D:D, hit enter. All right, and you can see that it's turned green so that we know that it's correct. All right, now let's do the median. The median is just as it reads, so equals median. Once again, D:D. If you want to type in the exact cell ranges, you may, but you don't have to, because when you do D:D, it simply grabs all the numerical values in that column. All right, so hit enter. The standard deviation, it tells you here in purple, we have a couple different choices. We can use stdev.s, that's the sample data, or stdev. All right, I'm going to use the simplified shorter version, so stdev. All right, and once again, D:D. All right, as you're doing this, everybody, make sure that your data is 2 decimal places, okay? 2 decimal places. Remember, if it's not 2 decimal places, you just have to go up here to the top and use your mouse to click on, or touch screen if you have it, to click plus or minus decimal spaces, okay, or places. All right, the range is equal to the max minus the min. So max D:D minus min D:D. All right. Oh, not C. That wouldn't work out very well. Sorry about that. Let's go back up here, click on it, and let's correct this. All right. Here we go. We got it. All right. So we have all of our values calculated for the 4 descriptive statistics for the wells before the treatment. Okay. Now, everybody, hey, just between you and me, okay? Let's just keep this between us. If you want to complete the rest of this table for after and before, we're wanting the data to go from D to E to F, right? So if you highlight the data here, notice I'm highlighting all 4 values. Grab the lower right-hand corner and drag to the right, all the way over. Yeah, that's right, all the way over. Just don't tell anybody else, but your table will be all done, okay? Yeah. All right. All right, now we want to find the percentile. It says for the improvement data, that is column F. We want to calculate the percentile of, in other words, the value that would be at the 16th percentile and the 84th percentile. So it says, note that 68% of the data falls between the 16th and the 84th percentile. All right, so how do I get that? It gives us the formulas right there. You can see it's percentile the data percent, right? Whatever percent you want. Make sure your percent in a decimal format. So just type in equals and then start typing, right? Percentile. The data is column F, which is F:(F). All right. And the percent they want here is the 16th percentile. So that's 0.16. All right. Enter. And it turns green. So we know we're right. What does that tell us? That tells us that the 16th percentile, the data value there is -15. All right. The outcome, the return is -15. Now we want the 84th percentile. The 84th percentile would be exactly the same thing, right? Precisely the same thing, except for what? You guys tell me, what would be the difference? Okay, I hear you. The difference would be simply type in 0.84 instead of 0.16, right? That's the percentile. Good. All right, so it tells us that 68% of the data lies between -15 to the left and -4 rather to the right. Now remember, everybody, in the middle, the 50th percentile is the mean. All right. The median or the mode. Okay, if it's a normal distribution, this is not specifically that, so we're not concerned about that. All right, next it says use the calculation above and the empirical rule to calculate the upper and lower limits from the improvement data. The improvement data is in column F, okay? Column F. I'm sorry. Column F, the improvement data is, the improvement statistics would be right here. All right. So I could go over here and calculate these very easily. Now I've got them. All right. The empirical rule, everybody says this. It says that 68% of the data lies within plus or minus 1 standard deviations from the mean. Okay. Plus or minus 1 standard deviation from the mean. So the lower limit would be the mean. I'm just going to click on it. The mean minus 1 standard deviation. 1 standard deviation is right here, right? So that's K9 minus K11, and it's -14.69. The upper limit would be the mean plus 1 standard deviation, right? So it equals to the mean plus 1 standard deviation. All right, hit enter. So this says the data values go from -14.69 to -3.94. If you compare that to the percentiles up above, it's really, really close, right? If we rounded it off, they'd be the same. Since we did not round them off, they're not the same. All right, everybody, as you're doing this work, check to make sure that all your decimals are correctly placed at 2 decimal places, okay? All the way down through. Next, go down here and don't forget to write in your answer in the text box. It says, what, if anything, do your calculations in part 4 tell you about the effectiveness of the treatment of the wells, i.e., how many wells are expected to see improvement within this range? Justify your answer using the lower limit and the upper limit found in part 4. All right, so you guys can ponder that question and answer that for yourself. And just a note here before we go. Everybody, over here is the answer key. Notice the different shades that they turn, the colors, the text, that it's a slightly different setup than we've had prior to this. So just letting you know, that should do it, guys. All right, take care. I'll see you guys later. Bye-bye.